We will first start by selecting a SecOps role and intermediate. Once you log in, you'll need to click past the selected tooltips. Next, we'll access the Web API protection, and we'll also have to close these tooltips as well. The first part of the lab, we will be creating a web application firewall policy. We will name this policy Blocking App Firewall, and we will change the enforcement mode from monitoring to blocking. Next, we will create a origin pool. We will use this to connect to the public resource that we have in our lab environment, and we will use the public DNS record to find the IP address for this host. The host is listening on port 80. And we will also create a health check to monitor the health of the backend application. Once we've created the resource for the pool, we will create the front-end VIP configuration or load balancer. We will call this load balancer global, and we will give it the name of our assigned student number. We'll choose to manage DNS records automatically and select the pool that we previously created. We'll then select the name of our web application firewall policy that was created earlier, and then save and exit. Volterra will manage the DNS records within this environment. We can then go to the resource that has been created on the Volterra regional edge. We can emulate an attack by adding cat %20/etc password. This will simulate a remote code execution attack, and we can see that it is successfully being blocked. We can also see metrics about our application by clicking on Performance and then the Global Load Balancer. Here we can drill down into the request logs of the successful requests that are coming in. We can also use the security menu to view security events as well. Here we'll see an overview via the dashboard, and via security events we can see detailed information about requests, and by expanding the details we can see the details of the attack and the signatures that were used to block the attack. Next, in our lab, we will be making use of a VoltMesh node that has been deployed into our AWS environment. Here we can see metrics from our VoltMesh node that is deployed within our AWS VPC. We have already created this resource, but here you can see an example of how you could create additional resources. The lab also provides a link to our Volterra simulator, where you can click on the Connect AWS VPC site if you'd like to see the actions that were taken previously to create this lab environment, where we specified the necessary information from our AWS environment to create this site. Please refer to our lab environment diagram for further details. Next, we're going to make use of our VoltMesh node to connect to a resource in our lab environment that does not have a public IP address. In this case, we're going to specify the private DNS name that lives under f5demos.internal that is local to the AWS environment. And we're going to specify that we want to connect via the VoltMesh node that we have deployed in our AWS VPC. And this particular resource is listening on port 8080. We'll make use of our existing HTTP health check, and we've now created a private origin pool. We will next modify our HTTP load balancer to make use of this private pool. We will modify the pool from public to private and save the changes. We can then revisit the page and see that it has changed from a public endpoint to the private endpoint. Next, we will create a topology where we will deploy a VIP on the VoltMesh node that is in AWS. Previously, we were sending traffic to the Volterra regional edge that is hosted in F5 data centers, or POPs. In this case, we will be making use of the elastic IP that is attached to the VoltMesh node to access the service. And we'll be referencing the private resource that we previously created. Prior to this lab, we also created a wildcard DNS entry that points to the elastic IP within AWS for the purposes of this lab. We'll specify that we only want to listen on the interface that has the elastic IP attached, and that the location of it is our VoltMesh node that is in AWS. We'll attach the same firewall policy that we had deployed on the regional edge, now in what we refer to as our customer edge, or a VoltMesh node that is running in the AWS lab environment. Take note that the DNS name is under a DNS that is not being managed by Volterra. This connection is now connecting directly through VoltMesh and bypassing the Volterra regional edge network, but it is also enforcing the same policy. In this lab, we made use of the external interface, but if you had the need to protect internal resources, you could deploy the service on the internal interface to protect internal load balanced connections. In this next lab, we'll look at how we can use the support ID to find a blocked attack and also allow it through in case of false positives. First, we'll collect the support ID, and then we'll go back to our security events. We will need to refresh the page to make sure that we have the entry that includes our most recent entry. And we'll want to search by request ID. We can paste in the value of the support ID, and you'll see that the search results will filter to that specific support ID. We can then create a WAF exclusion by selecting the Actions menu and creating a WAF exclusion. A WAF exclusion is tied to the load balancer object. We'll need to save the load balancer object for the change to apply. And once the change has applied, we can reload the page, and we'll see that we are now allowing the connection to go through. We can also examine the subsequent requests to see which WAF exclusion rule was applied by expanding the details and viewing the policy hits. This concludes the walkthrough of the Volterra WAF lab. Thank you very much.